All right, problem 11. So we have a diagram of a circle with a center at C. We have a point on the circle, which is A. And then we have K, which intersects the circle at point A, and only at that point A, which means it's tangent. Okay, and we can see that it's telling us all these things. We have line K is tangent to the circle with center C at point A. It's tangent at point A to the circle, and that's shown. So then it wants to know what the slope of line K is. All right, in order to find the slope of line K, we could use our slope equation, right? So our slope equation is m equals y2 minus y1 all over x2 minus x1, right? And that's for our ordered pairs, which would be like, we need two sets of ordered pairs, would be like x1, y1, and then we need like an x2 and a y2, right? So we could do that, but we only have one point that's on the line K. So what we can do instead is find the equation or the slope of the line perpendicular to it. So this is K, right? So we'll call this line L. I like to use my loops for an L because when you write L's and ones like that, they look kind of similar, right? So instead, if you have a one like that, and this is your L, they look different. So this is my L. Now we want to use all of our information. Remember, it's super important whenever we have a question. If it's telling us something, there's probably a reason it's telling us this, right? So line K is tangent to the circle. So let's use this piece of information and talk about it. So the tangent to the circle means that there's going to be a right angle there between the diameter and then the tangent line. So the diameter is going to cross through and be part of that line L. So we can find the slope of the line L because we see that we have 2 points on the line. So we can use our slope equation, okay? So we have m equals y2 minus y1. Let's call C x1 and x2. Let's call A x2 and y2. Or x1 and y1, sorry. Even we make mistakes, even teachers make mistakes. x1 and y1, x2 and y2. So then our m is going to equal y2, which is -5. Right here, -5. Minus, in parentheses, because it's going to be a negative value because they're all negative. We like to put our negative values into parentheses because it helps us keep our sign straight, especially because we have a negative in our formula, right? So our equation is not going to be -5 minus 7, for example, or -4, right? So we have a -4 in here. When we plug it in, we have -5 minus our -4 because our y1 then is 4. We want to make sure we keep these straight because we have two negative signs here, not just the one. So our equation isn't on top -5 minus 4, it's -5 minus -4, or -5 minus -4, which is going to be being a positive because we have two negatives. So making sure we keep that straight, we put that parenthesis in there just to keep them separate. So then our x2 is going to go on the bottom. Our x2 is -7. We subtract our -5 because that's x1. Our x1 is -5, so we should subtract our -5, again using parentheses to keep the negatives separate from each other. And then the nice thing you can do when you have two negatives separate in parentheses is you can just kind of make a plus sign with the left side of that parenthesis, and you can connect the two subtraction signs, and that makes it super easy. So we have -5 plus 4, which equals -1, and that's all going to be over -7 plus 5, which equals 2. So we can see that our slope for the line L is going to be equal to -1 over 2, because -5 plus 4 is -1, -7 plus, -2, making all kinds of mistakes. So -1 over 2, -2 is a negative divided by a negative, which is going to equal a positive 1 over 2. But are we done? We're not quite done, because this is the slope for line L. So for L, we'll call the slope m sub L equals 1/2. And then we know that if we have a perpendicular line, the slope of that line that's perpendicular to it, so for example, MK, is going to be the inverse opposite. So in other words, the inverse reciprocal. of ML. Because ML, or because the lines L and M are perpendicular. L and K, sorry. L and K, they're perpendicular. This symbol just means perpendicular. So these two lines are perpendicular to each other. So because we know the slope of line L is 1/2, we can calculate by doing the inverse reciprocal. So then, for example, let's say we have 1/4. Okay, let's say our M equals 1/4. It doesn't equal 1/2. Let's say it equals 3/4, okay, to make it super easy. The inverse reciprocal is going to be, first of all, we need to find the 0 pair for that number. So the 0 pair, remember, is the number that makes it add to 0. So it's going to be the negative version of that number, which is negative 3/4, okay? And then we take the reciprocal of that, which means we're flipping the top and the bottom. So we carry our negative sign, and our 4 goes on top, our 3 goes on bottom, and we see we have the inverse reciprocal. So our sign changed from positive to negative, and our numerator, changed to bottom denominator, and likewise our denominator, the bottom, changed to the top, the numerator. So then, if we have a slope of 3/4, the perpendicular slope to that line is going to be always -4/3. So we do the same thing with 1/2, because our M sub L equals 1/2, so we find the inverse reciprocal of ML, and that's going to be our slope for K, which is what we're trying to find here, the slope of line K, which is what we're calling M sub K. So then MK is going to equal the 0 pair for 1/2, so the negative value of 1/2, which is -1/2, and then we flip the top to the bottom and the bottom to the top, which is going to give us -2/1, which equals -2. So MK equals -2. We can see that as the opposite. If you guys want to put -2/1, just keep them straight and then look for the answer that way. That works. But our answer is -2. So we look for it and we see that it is -2, which is A. Be careful that you do not just stop when you find the slope of 1/2, because you see that is an answer. They're trying to trick you. Make sure you actually follow through with the problem and do what it's asking you, which is not to find the slope of line L, but to find the slope of the tangent line